Hey, Maureen. Uh, for the lunchtime, you asked me about this S and R configuration, and I'm so sorry I confused with the wedge and dash part. I want to give you a quick glimpse again, so you can have this video maybe later on if you want to listen to again, then you get it eventually. And first of all, I need to ask you, where is your chiral site? You need to find the chiral site first, right? So today lunchtime you told me there is what? Two. Okay, there are two you identify. Which one is it? The one in right here and the one right here, right? So you found that two. Now you start comparing with which one is the highest priority, right? Before I say that, first thing that I want to tell you, with the wedge and dash that I confused to tell you about it, the one was looking like a bolt and called a wedge. This should be a highest priority. If this violated, like this, your highest priority element actually has the lowest, such as like a hydrogen taking over, whatever the lowest is, take over this wedge, then you need to flip. Flip means you have to change the configuration. That's the rule. And if your dash, this should be a lowest. However, just in case if your highest, in the opposite case, your highest element, whatever it is, oxygen or something, when you do the configuration numbering, like number one, first priority takes over this lowest, then you have to flip again here too. This is the thing that you need to remember holding the structure. Usually these are like that. The highest is the normal, the dash would be the lowest. But when it comes in the situation, the hydrogen, like the lowest priority, not the hydrogen, maybe lowest, the last, or lowest, take this, the wedge, then you need to flip. So there are two conditions, flip, right? The first thing that you see that with the carbon, you're looking at oxygen, carbon, carbon. Remember our element table, CNOF goes like this way, number 6, 7, 8, 9. So you see that definitely oxygen is higher prior than this carbon. So you put the number 1 right here, and then you go, which one is higher? The same carbon. You compare with nitrogen, oxygen, carbon and carbon. So you see the nitrogen is more higher because more number. So you compare the first, the same. Now second side is higher. So you put the number 2 and 3. Your lowest priority is not shown right now. So maybe I can draw your lowest priority like here or somewhere here. It doesn't really matter. That's your number 4. So you're saying that 1, 2, 3, 4. You see that 1, 2, 3, 4. 1, 2, 3, 4. You're clockwise. That's your R configuration. Now I'm going to the second chiral thingy right here. This unit is unique because you're going to see which one is your higher priority. Carbon, nitrogen, carbon. You definitely see the nitrogen is higher, right? You only compare the first side, carbon, carbon, nitrogen. So you say that this is number 1 priority. Now which one is higher? You still have the same carbon. And now you compare the second side, OH, OH, okay, the same. But however, this one is this way and the carbon has more. So they have more family. Now you give the number 2 right there. Now this is atom number 3. Your wedge is not shown. Wedge is not shown. What is the wedge right now? Because the number hydrogen always hidden. You can say this is your hydrogen. So what is this? This is the first case that I told you. Like if your lowest atom priority takes over the wedge, you need to flip, right? So this is the case. Even though the structure wise 1, 2, 3, 1, 2, 3, it's gonna be your counterclockwise, your S configuration. Because of the hydrogen right here stuck in the middle, it changed the whole thing. Now you're going to this way, your R configuration. That's the way I do. Okay, hope it helps. Good luck.